Good morning, students. Today we'll continue with our modulation. Remember, we define modulation and that it involves changing a parameter of the carrier signal in proportion of the modulating signal. Now, we'll look at the types of analog modulation. Now, modulation types, for us to understand it, we should understand the mathematical representation of a sinusoidal carrier. Let's look at this equation V equal to VC sine omega ct plus or minus phi, which is same thing as VC sine 2 pi fct plus phi. Remember, this angular frequency is same as 2 pi fc. Omega here is 2 pi f. So subscript C here stands for carrier. So when we see M, it stands for modulating signal. So this expression means that the value before this sign is the amplitude. Remember, sign of any value is bounded by -1 and 1. That's, you cannot get a sign of the value more than 1 degrees. So this value represents the amplitude, while this one represents the frequency of this. So this part is the amplitude part, this part is the frequency part, and while this is the phase of angle, the phase angle. Now, this shows the waveform can be varied by any of the properties: amplitude, frequency, or phase. So anytime we are varying the amplitude, we are having amplitude modulation AM. Anytime we are varying the frequency, we are having frequency modulation FM. And anytime we are varying the phase angle, then we are having phase modulation. So let's quickly define what each of them stand for. Amplitude modulation now, the information signal changes the amplitude of the carrier wave without changing its frequency or phase. Remember, here we have three properties or parameters we use to describe a sinusoidal carrier: amplitude, frequency, and phase. So when it is just the amplitude that vary and the frequency or phase remains the same, we have amplitude modulation. But at the same time, when we use the information signal, which is the modulating signal in this case, to change the frequency of the carrier without changing its amplitude and phase, then it is what? Frequency modulation. In the same vein, when just the phase varies, the amplitude and frequency remains the same, it is phase modulation. Now, we can use the analogy to explain what we mean by this modulation. Let's look at an instance of somebody trying to throw a naira note or something valuable but with less weight, such as naira notes, to somebody on top of a building. Suppose the person throwing the object is just at the ground floor and is to throw it to somebody at the third or second or even the first floor. You will realize that throwing the naira notes will not be easy. Even when you fold it, the air resistance will just make the money fall back to you without reaching the target. But you can make a simple case of wrapping the naira notes around a stone, a relatively heavy stone. By the time you wrap it around it, you can throw it and the person can now get the tool, remove the stone from the naira note and use the naira note. So this is analogically what happens in modulation. The modulating signal is the information signal you want to send, which you can liken to the naira note, while the carrier wave is the stone. Analogically, the amplitude modulated wave in this case now is what we the stone plus the naira notes that the person will get. So on receiving it, he will now remove the stone, which is the modulation now, and then get the naira note, which is the modulating signal. So the modulation is just reverse of modulation, where the carrier will now be separated from the modulating signal at the receiving end. At the transmitting end, we put the modulating signal to change the property of the carrier, and then we get the amplitude modulated wave. Now let's look at this AM transmitter system. Simplified block diagram of AM transmitter system. What we produce, you know, we need a transducer. Suppose we want to broadcast from a radio station. The newscaster, for instance, will use microphone to record the audio signal, the audio, which is sound energy in this case, and the energy we get is now the input signal into the modulator, which is the mixer in this case. So you produce something in audio frequency range, because our speech is in audio frequency range. It is still bounded by that 20 and 20 kilohertz. You can't hear something more than that 20 kilohertz or something less. So that's the input signal. This oscillator will now produce the carrier. The oscillator produces the carrier wave, and this mixer now, which is the modulator, mixes the two and produces an AM wave, which is now in radio frequency domain. The carrier is also radio frequency domain, but by the time you mix the audio frequency and radio frequency, you get radio frequency, which is high frequency. Our ear cannot detect this. That's why it's in radio frequency domain. This we will discuss later. It is radio frequencies between 3 kilohertz and 300 gigahertz. So by the time we get the signal, which is AM now, we need to amplify, because it will be a weak signal, so that we'll be able to make it travel fast. Far we can amplify. So using an amplifier, then we send it to a transmitting antenna, then it radiates into space. At the receiving end, reverse of what happened here will take place. It will still be amplified, and then it will be demodulated, then you get it, and blah 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 blah. Instead of the microphone here, what do you use at the receiving end? It's the speaker, for you to get the sound. Now let's look at this AM wave. You remember, you see here that you have unmodulated carrier wave, which has this amplitude. It will have the same frequency all through, but the modulating signal, which is something just like this that we use to wrap it, is called envelope. This envelope is just a replica of the modulating signal. The information signal, we use it to wrap, just like we talk about the neural node. This is the neural node that you use to wrap around the screen. So it just repeats what you have here, but this is the amplitude of the carrier that has not been modulated, which is the radio frequency signal. It's like that. You see here, from here to here is VC, and what you have from here to here is VC2. So by the time you modulate it, you have this envelope around it, and then here you just turn it upside down, reverse of what you have here. So we'll use a numerical value to explain this better in our next class. So have a good day. God bless you.